Hi, today we'll be going over the solutions in our portfolio that allow you to create workflows that integrate applications, and also we'll show you an example of a web-enabled deploy solution that builds on the workflow and allows expert simulation users and, more importantly, non-experts to execute these workflows. Before we dive into the details of these solutions, let's just quickly revisit the evolution of simulation-driven solutions that we observe commonly. It's not uncommon that when analyzing the performance of a product, simulation teams start by understanding and manipulating ASCII files that represents the details of the model. As the simulation solution matures, the simulation model that builds directly on a GUI is created and represents the next evolution of the solution for this product. Next, dedicated GUI that presents the user with dedicated fields to provide inputs to the model is sometimes created, and this third phase represents something that resembles more of a templatized approach. Lastly, in order to drive the adoption for this templatized solution more widely, the challenge of looking for a global centralized deployment is presented upon the simulation team. Now, prior to global deployment, we recognize that the prior stages through which the simulation-driven solution evolves have challenges that limit its wide adoption. Here are some of the common challenges that we observe. The interfaces are built with experts in mind. The simulations are locally managed and executed. While templatized, there is still room for deviating from best practices. There is a lack of version control and risk of executing outdated solutions. And lastly, due to the locally managed aspects, the potential for data proliferation is quite high. Going forward, we'll see how our solutions in the 3D Experience platform allow simulation teams to create standardized workflows that integrate their existing applications and create web-enabled solutions to facilitate their global deployment and use. So what makes our solution different? The solutions are designed so a centralized team of experts assumes the unique role of integrating the workflows and deploying the solutions globally. The process integration solution is general purpose, so you will be able to preserve your preference for the various software that contribute to the overall workflow. Because our solution is deployed with inherent document management capabilities, version control across the various pieces of the workflow is enforced naturally. On the solution deployment side, the centralized workflow would be able to be deployed globally as well as leverage compute resources dedicated for this purpose wherever they are. The experts as well as the non-experts would be able to access the deployed solutions via any device, dedicated computer, tablet, or a mobile phone. The front end of these web-enabled solutions hides all the complexities associated with special purpose simulation tools, facilitating their adoption. Lastly, data and project management solutions inherent to the 3D Experience platform can be leveraged as part of the overall business process, driving the creation and execution of these solutions. Now that we have some context, let's look at an example of these solutions in practice. Here's an example of a templatized Abaqus model that is used to predict the behavior of a 6-inch horizontal crack present in a wellbore. The wellbore is idealized as a plane strain model looking down the well axis. This model is used to predict the opening of the crack due to the thermal and mechanical operational conditions of a section of the well, which change depending on the well depth. The model can take any thermal operational conditions as well as anisotropic horizontal stresses and in situ conditions for this portion of the well. So, having created this model in Abaqus CAE, we'll see how we can create a workflow that integrates the various tasks executed in the overall process and then create a web-enabled template that can be deployed globally to experts and non-experts alike. Now that we talked about the application that we're going to use our solutions for, Now let's dive into the details of the two solutions. First, we're going to look at the process integration tool. And then secondly, we're going to look at an example of a web-enabled solution that builds on the process. So here is what the workflow for this application looks like. So in this case, we're going to ask the user to provide some input. And with the user input, we're going to actually use it to configure the thermal and mechanical analysis, as well as some of the post-processing, and automatically report the results back to the user. Well, first, let's look at some important information in the workflow. The workflow relies on input, and parameters are used to capture that. So here we have the information relevant for the analysis, and also scaled versions of that that are used to configure the Abaqus thermal and mechanical analysis. Let's take a look at each of the components in detail. The scale version of the user provided input is accomplished with this calculator component. The next component actually downloads the Abaqus Python scripts to the user working directory. The three text parsers that follow replace the user provided input into the relevant fields so that a new Abaqus model can be configured. The new Abaqus models are executed using this command prompt tools automatically. This script tools captures the results of the Abaqus models and builds an array that is used for downstream visualization. And lastly, an ASCII file containing the results of the crack opening is actually uploaded to the workflow. Workflows like this, and of much greater complexity, can be configured with all the tools that are shown here at the bottom of the interface. Now that we talked about the process integration aspects of our solutions, let's take a look at now the solutions that we have for deploying those workflows using web-enabled templates that facilitate the adoption of these simulation-driven solutions. So this is an example of such a web-enabled template. Again, it builds upon the workflow that we previously created and talked about. So let's take a look at the different sections of this web-enabled template. In the first part of the template, the user can provide relevant information for the geomechanical assessment that needs to be completed. In the middle, we have all the inputs that are provided by the user. It's worth noting that in the template, we can actually ask the user for information in the unit system that is consistent with their practice. So for instance, here we have inches and pounds per gallon. And in the bottom section, we have the results that are produced by the execution of this workflow and that are reported to the user either by graphically interacting or with ASCII files. Now that we covered the different sections of the web-enabled template, let's configure a new job. So we're going to perform a geomechanical assessment for an identified weak zone in a particular well in a particular field. So the user will provide the relevant information in these fields. So now that we provided that information, we're going to specify the different inputs to the assessment. So we're going to change the mud temperature and also change the mud pressure, provide a slightly different mud weight, and also provide a slightly different characterization of the minimum horizontal stress. So having provided those, now we're going to launch the execution of the assessment. So the execution takes a few minutes and the new results are reported to the user in this graphical user interface. So the user can interact with an XY plot reporting the behavior of the crack, as well as download an ASCII file that was uploaded automatically by the workflow so the user can interrogate the numerical values of the crack opening across the crack length. Thank you for your attention. I hope you enjoyed this material.